section 12.4, we're going to take a look at properties of logarithmic functions. So in section 12.3, we discussed about what logarithmic functions were, and now we're going to take a look at some of the properties of these functions. So here's again a look at your homework, a page of your homework. And the ones that are highlighted are the ones that you're going to be looking at. But of course, we're going to do more than the ones that you're looking at here. So let's proceed with our first property. It's going to be, I think, about 5 properties in this section. So the first property we're going to look at is called the product rule. The rules or properties, we use them interchangeably. So our first property or rule is going to be the product rule. The product rule here tells us that if you have log of a product, the reference to product here is in the argument of the logarithm here, not the product on the right side. There is no product on the right side. So we have log base a of m times n, and we can write this as the sum of two logs, m plus log n. And that's what this is. Let's take a look at an example of this property. Exercise number 8. We have log base 2 of 16 times 32. And using the property, so m is 16 and 32 in exercise number 8. So we can write this as log of 16 plus log of 32. And that's all we're done with this one. They just want us to rewrite them in using the product rule, and we did. In exercise number 12, we have log of base t of 3ab. Now, although the product rule up here, you're seeing it with m and n, it actually extends to beyond mn. So if we have m, n, o, p, q, and so on, you just keep adding those logs of m plus n plus p plus q and so on. Therefore, for number 12, log of 3ab becomes log 3 plus log a plus log b. In number 14, we have log of 5 plus 9. Now, in this segment, they want us to actually write it as a log of a single expression using the product rule. So we're going from right to left instead of left to right on that product rule. Log of 5 plus log 9, we can multiply the arguments 5 times 9, and 9 times 5 would be 45. And that was, so these are examples of the product rule. Next, we're going to look at the power rule. For the power rule here, the power p appears as a power on the argument of the logarithm, not the power on the whole log, but just the power on the argument. And when that is the case, we can bring p in front of a log. So this is going to be p times log of m. So we can write it, in other words, in factored form. So the log of the power is the exponent times log of m. Again, the power rule allows you to move the power in front of a log. Here's an example, number 18. In number 18, we have log of t to the 5th, whatever the base. So the power moves in front of a log as a factor, and we have 5 log t. And that's all in this one. In number 22, we have log m to negative 5. Again, we're going to bring negative 5 in front of a log. And that's done. You can see most of these are pretty quick. The quotient rule is our next rule. With quotient rule, again, here the reference to quotient or fraction or division rule is in the argument of the logarithm. So m over n, the fraction, is the argument of a log. And we can write that as log of m minus log of n. So quotient of logs become difference of logs. Here's an example of this one. In this example, number 24, we have log 29/13. This becomes log of 29. The numerator is first, denominator second, and you subtract log of 13 from log of 29. In number 26, right next to it, we have log of y over x. which becomes log y minus log x. And number 30, we have log of 26 minus log 2. Now here's a case again, we're going to go backwards. So if we're given difference of two logs, we're going to write it as log of a quotient. So 26 minus 2, this becomes 26 divided by 2. And I went ahead and did 26 by 2 is 13. Next property, this one is the log of a base to an exponent. So this one, now here's note, the base of the log is a, and the argument of the log is exponential form with base a. So base of a log, base of the exponent are the same. So you simply write this as k. An example of this one, I just made up one because I couldn't find one in the exercises. So for example, if I have log base 5 of 5 squared, that becomes just 2. Some bring 2 in front of a log, and this becomes log 5, and that's 1. And you get 2 that way also. But I just went ahead and illustrated the property. Right next to that, I have log of x cubed in base x. That's going to be 3. Log pi, log of pi in base pi. Pi to the 4th is just going to be 4. Now, this is a summary of the properties we just talked about. Now, in this summary, up here are the properties. First one, this is the product rule, the quotient rule, the power rule, and of course, log of a base to an exponent. That's this one. So we had 4 of them. And remember, we had 2 from previous section also. And that was log 1 in any base is 0, and log AA is 1, right? We had those 2 also. And maybe I should write them instead of just saying them, huh? So let me actually remind of those 2 properties we had. One of them that we had was this one. And this is the one I want to write. Okay. So we had log base a of 1 is 0. Remember, log 1 in any base is 0. And then we had log base a of a is 1. This is the base down here. Up here is a. Again, we had these from previous section. So in all, we have 1, 2, 3, 4, 5, 6 of these properties or rules. Now, the Quotient part here actually is pretty good. I like this one. The Quotient part here, it tells us that this is how we can actually mistake these properties. So for example, when if we have log of a sum, that doesn't equal sum of the logs. Remember, that was the product rule. Or if you have log of a product doesn't become product of logs. Log of a difference doesn't equal difference of logs. Right, that's this one. And finally, log of a quotient doesn't equal log of a quotient doesn't equal quotient of logs. So that's what these are about. Okay. And I want to make sure that this is going. Okay, and that's just a summary of those. Now let's take a look at number 38. In exercise number 38 here, we are given an expression that's log of a single expression here, right? X, y squared, z to negative 3. And in this exercise, they want us to write, or I should say rewrite, this logarithm as log of just x, just y, and just z, not their product. So I went ahead and applied the multiplication rule to x, y, z. That becomes log x, log y squared, log z, negative 3. And then next I use the power property of logarithms. The 2 moves in front of a log. That's over here now. And then negative 3 on z moves in front of a log and becomes negative 3 log z. And there you have this one. Okay, again, pretty simple. So we had log of a single expression, and that became log of individual x, y, and z here. Okay. Now let's take a look at our next, sorry folks, our next exercise. This is number 40, which is a bit more elaborate. Okay, again, I'm not sure why this keeps coming up. Let me delete this one. Okay, now for exercise number 40, make sure there's nothing there. Okay, in exercise number 40, so the expression is log of x to the fourth divided by yz squared. So with the quotient rule, remember, we write the exponent, the numerator, minus everything in the denominator. So I did log of x to the fourth minus. Now in the denominator, if you note, we have a product of y times z squared. So I went ahead and applied the multiplication rule to the denominator. And I also brought 2 in front of a z, so we don't have to put too many steps. That's what I did in one step. So here's the numerator again, minus the denominator is in the bracket. And then I moved the 4 on x in front of a log, distributed the negative sign to log y and to 2 log z. And that's all you have to do with this one. We're done with number 40. In exercise number 46, which I hadn't assigned anything like it, but you know, it's good to see it. So I'm sure some of you may like this one. Of course, it's more challenging than number 38 or number 40. So for this one, we have log of the fourth root of that expression in radical. So the first thing I did was I actually rewrote using the properties of radical exponents. Remember, rational and radical exponents. I rewrote it as the fourth root of anything would be that thing, the radicand, to 1/4 power. That's going from radical to rational exponent. And then what I did is I actually used the power property of exponents. I distributed the 1/4 to every power inside parentheses to the top. 1/4 distribute to 8 means 8 times 1/4. That becomes 2. 1/4 times 12 becomes 3. 1/4 times 3 becomes 3/4, and 1/4 times 5 becomes 5/4. And the next step is almost the last step. Still got 2 more after that. So next step, what I did is I applied the quotient rule. So log of the numerator minus log of the denominator. That's where the minus is here. Now, in the numerator, we can move 2 in front of log x, right? Because 2 is the power on x. So I moved it to the front in the next step. Oh, first in the numerator, I applied the product rule. As you can see, x squared times y cubed becomes log x squared plus log y cubed. In the denominator, I did the product rule also, by the way. Log of a to 3/4 times log of z to 5/4. And then I distributed the sign, the negative sign, to both logs within brackets. Move the 2 in front of a log, move 3 in front of a log y. And that will give me the next step. Now 3/4, by the way, here inside the bracket, the 3/4 moves in front of a log. The 5/4 move in front of a log z. And of course, remember, once 3/4 moves in front of a log, then this is just log AA. And log AA, we had the property. That's just 1, true? And this is the property I have up here, right in here. Log AA is 1. So that's the property I used. And of course, tidy up the last step. 2 log x is here, 3 log y is here. Negative 5/4 log z, I put that next, so all the logs are happening first. And then minus, this is 1 times 3/4, 3/4. Now please note that this is not log z minus 3/4. So it's everything, and then of course, and this is what I mean by everything. It's all of this, and then minus 3/4. So the negative 3/4 just comes in the end after you combine everything else. Hopefully you follow this one. This was exercise number 46. Again, rather elaborate exercise. I had not assigned anything like this, but I thought again it would be nice to see how that's done. Excuse me. Okay, in number 52, now we want to do actually something different. Let me take you back to the easy one, number 38. In number 38, imagine if we go from right to left. So in other words, let's say I have something like this and I want to put them back together. So we begin with the coefficients, all the numbers in front. They move to the exponents. This one moves to the exponent and we go back to where those came from. And then once all the coefficients are 1, 1, and 1, there are no numbers outside of the log, then we begin to use our product or quotient rule, whatever it might be. Because these are pluses, so we're going to use the product rule in reverse. So sum of the logs becomes log of their product. So that's kind of what we want to do in this segment, our next segment. And there you have it. That's what this one is. So in number 52, we are given 3 log p, half log t, negative log 7. So remember, first you move all the coefficients, the numbers in front, in the exponent as an exponent on the argument of the log. So 3 goes as a power on p. 1/2 becomes the power on t. And some even put it like negative 1 as a power on 7. So it becomes 7 to negative 1. I did not do that. Didn't want to confuse you, but you could. So anyway, that's my next step right here. And then once all the coefficient, the numbers before log is 1, 1, and 1 here. Don't worry about the negative, but the number is other than 1. If it's other than 1, you move it to the exponent, but if it's nothing, then we're done. Now, next step, we actually apply the product and the quotient rule. So sum of the logs become log of a product. The difference becomes a quotient, and the log that appears after the minus sign, the argument, goes in the denominator. And that's what I've done here. So p cubed plus t to a half becomes log of the product. P cubed times t to a half. Because I have negative log 7, the negative tells me that 7 goes in the denominator. And I rewrote t to a half as just the square root of t. Okay, the exponent, that 3 that you see here is actually, let me clear that up a little bit better. That 3 is an exponent on p. Okay, so maybe I even do better than that. Let me just kind of bring this p cubed out. Just want to make sure that you don't, by mistake, there you go, do something that's not correct. That's what I meant by p cubed, and square root of t, that's t to a half, right? Okay, and how did that happen is because, remember, one of the properties we had was a to the m over n is the nth root of a to the m. Okay, that's what I used with t to a half became square root of t. Okay, that was in chapter 10. We're done with this one. In number 58, I believe that's the last one. Yes, number 58. We are given log of 2x plus 10 and then minus, right in here, minus log of x squared minus 25. Now, this log, because of the minus between the logs, that becomes the quotient of the logs. So that's what happens next. So I wrote it as a quotient. And then that's the property of the logs. Actually, the next step is an algebraic step. What I did next was this. In here, the numerator, I factored the GCF, which is a 2. So 2x. 2 removed from 2x leaves me with x. 2 removed out of 10 as a factor means product becomes 5. 2 times 5 is 10. 2 times x is 2x. So I get back what we started with. In the denominator, actually, this is difference of 2 squares. Remember the factored form for difference of 2 squares. Maybe I'll write that for you in case you may have forgotten it. We said a squared minus b squared. Remember, that would be difference of two squares. The factored form is a minus b times a plus b. And that's what I did in the denominator of that fraction. And of course, the next step, we divided out the common factors, and that left me with a 2 on top and just x minus 5 on the bottom. And that is the answer to exercise number 58. So we are done with this section, and hopefully you were able to follow all this good stuff. And we are through chapter, well, not the chapter, but section 12.4. We're done with that section. And again, hopefully you followed everything we did in this section. That completes section 12.4 for us.